Multiplication properties of exponents. Our objective is to use multiplication properties of exponents to evaluate and simplify expressions. Who uses this? Astronomers can multiply expressions with exponents to find the distance between objects in space. Let's start with some general guidelines. Simplifying exponential expressions. An exponential expression is completely simplified if there are no negative exponents. The same base does not appear more than once in a product or quotient. No powers are raised to powers. No products are raised to powers. No quotients are raised to powers. Numerical coefficients in a quotient do not have any common factor other than 1. For example, b divided by a, x to the third, z to the 12th, a to the 4th, b to the 4th, s to the 5th divided by t to the 5th, 5a squared divided by 2b. These are examples where things are completely simplified. These are not examples. A to the negative 2 times b a. X times x squared. Z to the third, that quantity to the 4th. Or you've got a product AB raised to the 4th. Or a quotient s divided by t raised to the 5th. Or in here, notice how you have 10a squared divided by 4b. Well, they have a common factor other than 1. So let's start with the product of powers property. The product of two powers with the same base equals that base raised to the sum of the exponents. So like 6 to the 7th times 6 to the 4th is equivalent to 6 to the 7 plus 4, which would be, in this case, 6 to the 11th. Let's practice. So we have 2 to the 5th times 2 to the 6th. They both have the same base, so we can add their powers. So we have 2 to the 5 plus 6, which is equivalent to 2 to the 11th. Let's try b. Notice how not all of them have the same base, but we have 4 squared and 4 to the 5th. They have the same base. So we can put those ones together. So we can put 4 squared and 4 to the 5th together. And then we can put our 3 to the negative 2 and our 3 to the 6th together. So when we have 4 squared times 4 to the 5th, that's really 4 to the 7th. And then we have 3 to the negative 2 times 3 to the 6th. Well, negative 2 and 6 make 4, so we have times 3 to the 4th. Take a moment and pause the video and try C and D on your own. When you return to the video, the answer will be revealed below. In C, you have a to the 6th because you have 4 and 2, which makes 6, and b to the 5th can't be combined with anything, so it just stays on its own. For D, you have y to the 2nd times y to the 1st. Whenever there's no power, you know it's 1. So you're adding 2, 1, and negative 4, which gives you y to the negative 1. You cannot stop there. It's not completely simplified because you have to have everything with positive exponents. So rewrite this so it says 1 over y. You can write 1 over y to the 1st if you need to. Now let's look at an astronomy application. Light from the sun travels at about 1.86 times 10 to the 5th miles per second. It takes about 500 seconds for the light to reach Earth. Find the approximate distance from the sun to Earth. Write your answer in scientific notation. So we know that distance equals rate times time. So we have our rate, and our time, which is our 500 seconds. So there's a few steps we have to take in here. So step 1 is going to be to write 500 in scientific notation. So now that you have both of these looking similar, we're going to put our 1.86 and our 5 together, and we're going to multiply our 10 to the 5th and our 10 to the 2nd together. So now when we multiply, we end up with 9.3 times 10 to the 7th, because 10 to the 5th and 10 to the 2nd give you 10 to the 7th, and when you multiply these, you get 9.3. Therefore, the Sun is about 9.3 times 10 to the 7th miles from Earth. Power of a power property. A power raised to another power equals that base raised to the product of the exponents. Let's look at an example. If we have the quantity 6 to the 7th, that quantity to the 4th, you're going to have 6 to the 7 times 4. So whenever you have a power to a power, you multiply. Whenever you're multiplying common bases, you add the exponents, which is what we just did. So a power to a power, you multiply. So 6 to the 7th times 4 is really 6 to the 28th. Let's practice this rule. So we have 7 to the 4th, that quantity to the 3rd. So we can rewrite this as 7 to the 4 times 3, which is 7 to the 12th. For this one here, we have 3 to the 6 times 0, which is really 3 to the 0. We can simplify that one more step by saying, well, that's equivalent to 1. Well, take a moment and try C on your own. When you return to the video, we'll see how close you came. Alright, so to rewrite this one, we'd have x to the 2 times negative 4, which is really x to the negative 8th. And then we have our x to the 5th. However, we are not done yet. We have both of these with the same bases. So when you multiply common bases, you're going to add the exponents. So this time we have x to the negative 8 plus 5, which, if we simplify, is x to the negative 3rd. However, we cannot have a negative exponent. So if we simplify this, we're going to have 1 over x to the 3rd. Now let's try power of a product property. A product raised to a power equals the product of each factor raised to that power. So say you have 2 times 4, and then that quantity is raised to the 3rd power. You can rewrite this to say 2 to the 3rd times 4 to the 3rd. Keep in mind, this works because you're multiplying. You can't do this with addition and subtraction. It's the power of a product property. Okay? So 2 to the 3rd is 8, 4 to the 3rd is 64. 8 times 64 gives you 512. Let's practice this property. So we can rewrite this to say negative 3 to the 2nd times x to the 2nd. Well, negative 3 to the 2nd is 9, and you can't simplify x to the 2nd, so we're just going to rewrite it. Notice how in B, the negative symbol is outside. It's not inside with the 3. That means it's going to hang out till the end. So we have this negative outside here, and then we have 3 to the 2nd times x to the 2nd. Well, 3 to the 2nd is 9. Once again, we can't do anything with this x squared, so we're going to simply rewrite it. And this negative sign comes down in front. Let's look at C. So we can rewrite this to say x to the negative second to the third times y to the 0, that quantity to the third. Well, we have a power to a power, so we multiply. So now we have x to the negative 6 times y to the 0, because 0 times 3 is 0. We're just going to bring it up over here. So we have x to the negative 6 times 1, because anything to the 0 power is 1. And now we have this x to the negative 6. We have to make this a positive exponent. We don't want a negative. So what we're going to do is we're going to write it so that way it's 1 over x to the positive 6. So we have 1 over x to the 6th. And that is your final simplified answer. And that also ends our video lesson on multiplication properties of exponents.